Okay, let's try these practice questions. So I'm going to show you the shortcut method of doing this. And then for some of you, you're going to find that a bit tricky. And so then I'm going to draw a picture of it as well. For those of you where it makes sense, the answers are in the next slide as well. Okay, so, whoops. If you're following along in your notes, we're on page 8. Okay, so how many electrons are found in an ion of sodium with a charge of 1 plus? So remember, an atom is neutral, an ion has a charge. And an ion has a charge because it's gained or lost an electron. So I find the biggest thing with students is when they see that 1 plus, they think it's gained electrons. And that's not the case. If it's 1 plus, it's lost electrons. If it's 1 minus, then it's gained electrons. And if you think about it, electrons are negatively charged. So if you're picture in your hand that you're holding a bunch of these electrons that are negatively charged, and if I was to give you 3 more, you would have 3 more negative charges. If I took them away, you'd have less negative charges, so it's becoming more positive. If you find that confusing, I always say to my students, do the opposite of what the sign says with electrons. So if it says 1 plus, you would subtract 1 electron. 2 plus, you'd subtract 1 electron. 1 negative, you'd add 1 electron. 2 negative, you'd add 1 electron. Okay, so let's look at sodium. Well, we know that if you had sodium has, it's number 11. So if you had an atom of sodium, it has 11 protons and 11 electrons. But it's an ion, and we've been told that it is 1 plus. Okay, well, if it had 11 electrons, and since it's 1 plus, it loses, then it's going to end up being 11 minus 1, so it's going to end up being 10. Now, if you find that confusing, let's think of that in terms of a Bohr diagram. So if we've got sodium's number 11, and if we had a Bohr diagram, we would take sodium and we would end up having number 11. So it has, the neutrons would be 23 minus 11, which is 12. Okay, protons is going to end up being 11. That never changes. That's nice. Okay, so that part's no different. And in the atom, we have the same amount, right? So in 1, 2, we're trying to get to 11. 3, 4, 5, 6, 7, 8, 9, 10, right? And then the atom actually had 11. Now, we talked about valence electrons. Sodium is highly unstable. In fact, if you were in class, I would drop sodium in water and you would see it spark and start a flame and everything. It's highly reactive. And the reason why it's highly reactive is because it only has 1 electron in its valence layer. It's not full. If it's not full, it's going to be reactive. And the closer to being full or empty is going to make it even more reactive. So what this electron is going to do is it's going to want to lose that last one. So that would mean if it forms an ion, it's going to end up having 1 less. There's going to be nothing left in that last valence layer. And now I have 2, 4, 6, 8, 10. And now I have 10 electrons. Okay, so that's why it ends up being that 10. Okay, let's look at the next one. Calcium with a charge of 2 plus. Okay, if it was an atom of calcium, that would mean that it has 20 electrons, but it's an ion, 2 plus. So that means we're going to subtract 2 from 20. Okay, if I subtract 2 from 20, I'm going to end up getting 18. Okay, now let's try the next one. How many electrons are found in an ion with a chlorine with 1 negative? Okay, so 1 negative, which means it gained an electron. Chlorine. Here's my chlorine. It normally had 17. Okay, so if it has that 1 negative, it gained 1, so it's going to become 18. Okay, sulfur, 2 negative. Gained 2, because 2 negative, right? There's sulfur, so it was 16. Originally, when it was an atom, it had 16 electrons. 2 negative means it's going to gain 2, so it would be 18. And let's look at those again quickly, because if you're watching this, it's because it didn't make sense. Okay, so let's do calcium. Calcium's number 20 in the periodic table. So let's take calcium. And calcium would be, for neutrons, it's going to have 20. And typically we don't put the symbol in there. I'm just putting it in there so I don't forget. And then its protons is going to be 20 as well. Okay, so if it was an atom, then that's going to mean that in its first energy level, it's going to have 2. Second energy level is going to have the full 8. And I'm just going to double them up because I know it's going to be full, because I'm not at 20 yet. Okay, so far I'm at 10. I'm going to add another layer. Okay, and that's going to be 18. I'm just going to double them up one time because I know it's going to be full. Okay, and then the last layer would have 2. That would be an atom, but it's an ion. Now, can you see why it's going to lose 2? That valence layer is not full. So in this case here, if it's less than 4, you're always going to lose electrons. If it's more than 4, you'll gain. So if it loses these, okay, now we have 8, 8, 2. We end up having 18 electrons. And the other thing too is once you end up taking away those electrons, you put square brackets and you then end up having 2 plus. Because if you just drew this originally, so for example on a test, if I end up drawing something like this, I leave the center blank. And then I just draw the actual electrons itself. So let's say this was a test question and you were drawing and you were actually looking at this answer here. If I didn't have this information in here and the square brackets out here, you would look here and you'd say, okay, and again, I wouldn't have this valence layer here as well. You would look and you'd say, okay, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18. So then you'd go to your periodic table and say, okay, 18. So that's going to be argon. But it's not argon, right? Because if it's an atom, we know electrons and protons are the same. So by putting square brackets, that tells you, okay, you can't just go based on the electrons. You can count them, but then you have to add another 2 to the original so you know what the original substance was. When you saw, yeah, okay, so let's try another one here. Let's draw a Bohr diagram for an ion of oxygen. Okay, so oxygen is number 8. It has a molar mass of 16, so if I subtract the 2, then I'm going to end up having 8 neutrons. So I'm going to have my neutrons is equal to 8. My protons is equal to 8 as well. So remember, atom, ion, it doesn't matter. Protons, neutrons are always going to be the same. So you can't actually use those to figure out if something's an atom or an ion. Okay, so next, I'm going to end up taking my first energy level, and I'm going to put 2. Okay, and then now I'm going to grab my next energy level. And if it was an atom of oxygen, I'm trying to get to 8, so I'd have 6. 1, 2, 3, 4, 5, 6. There we go. But when you're looking at this diagram here, the last energy level is not full. It's an atom. So an ion is actually more stable. So in this case here, this one's going to gain 2 electrons to become more stable. So because I added 2 more electrons, the original one should have only had 8 total. Now it has 10. So to show that I've made an ion, I'm going to put square brackets around it. Because it gained electrons, it's going to be negatively charged. And then you have to tell me that how many you added. I added 2. So that's my ion. So your summative assessment, I'll have pictures like this. And your question is going to be, what is this substance? Okay, let's look at the next one. A calcium ion. Okay, well, let's take my calcium. We were just looking at that for the above. Okay, so calcium, if I find its neutrons, 40 minus 20, it's 20. So its neutrons is equal to 20. Protons, it's number 20, so it's going to equal to 20. Atom, ion, it doesn't matter, that's going to be the same. If I had an atom of calcium, then I would end up having, because it's number 20, then I would have 20 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, still not at 20. 11, 12, 13, 14, 15, 16, 17, 18. Now, normally I'd add another layer and I'd have 2 more on that layer. But if I draw those 2, it's unstable. That's the atom form. I'm trying to make an ion, which means it gains or loses an electron to become more stable. So I'm just saving myself a step, so I don't need to draw it twice here. So because I lost those 2 electrons, I'm going to put square brackets around, and I'm going to have 2, because it was 2. And it's going to be positive because I took away 2 of the negative electrons. So I take away the negative charge, it then becomes more positive. Now remember, at any point, if you're still confused, you can always contact your teacher. You can email your teacher and you can set up an appointment to meet with them, and they can meet with you virtually or in person to go over these in more detail.